Iwo Jima was not the first place flamethrower tanks were used, but it was among the most consequential in terms of scale and effect. The island's volcanic topography, with ridgelines, ash slopes, and intricate networks of fortified caves, favored defense by prepared positions. The initial assault on 19 February 1945 produced devastating casualties, and commanders quickly recognized the value of any weapon that could reduce infantry exposure when clearing bunkers and caves. Operationally, the flame tanks were a scarce and valuable resource. The Marine Corps did not assign them permanently to units in the way more generic armor was distributed. Instead, flamethrower tanks were pooled and dispatched to where they were most needed, often moving to the scene at the request of infantry units pinned by fire from a particular strongpoint. They landed on D-Day with the invasion convoys, but their most intense use was in the days that followed, as Marines pushed into the interior and encountered deeply concealed positions. The tank's psychological and practical value meant that assaults would sometimes pause until a flame tank could be brought up. Commanders preferred to delay and take fewer casualties than to charge into rooms and caves that could be neutralized by flame. Consider the logistics. Each flamethrower tank required specialized fuel, often thickened petroleum mixtures, pressurization maintenance, and trained crews who knew not just how to operate, but how to service the installation under combat stress. Seabees and chemical corps technicians accompanied operations to repair and refuel when possible. Fuel consumption could be enormous. At times, thousands of gallons were expended in a single day when the fighting concentrated around key sectors. Tanks that carried the flamethrower in place of their main armament needed support from conventional tanks for anti-armor defense. Periscope-mounted variants retained some of their original weapons but had other vulnerabilities. The net result was a tactical ecology. Flamethrower tanks were best used in combined formations with riflemen, engineers, demolition teams, and normal Shermans wielding direct fire. Their presence altered the tempo and tactics of assaults and required coordination and supply discipline to keep them in the fight. On the first days of the Iwo campaign, the flamethrower tanks provided dramatic, observable effects. There are documented cases of a tank approaching a cave mouth, projecting flame directly in and either forcing defenders out or neutralizing them in place. Infantrymen described the relief of having a mobile system that could reach into apertures no grenade could access, and tank crews described the unique challenge of operating a weapon that was both effective and, occasionally, a prime target. Royal Navy and British Commonwealth readers will be aware of the Churchill Crocodile and other Allied flamethrower experiments. Iwo's flame tanks built on that Allied thread, but had distinct American engineering and operational patterns shaped by Pacific conditions. The combination of terrain, dense fortification, and proximity made Iwo a crucible where the flamethrower tank's strengths and limits were starkly visible. Tactically, a flamethrower tank is both a weapon and a tool for shaping human behavior. The immediate physiological effect of flame on wood, canvas, or timber is obvious. Less obvious is the psychological pressure it exerts. The presence of a flame tank facing a fortification could cause defenders to abandon positions when they otherwise would have held, because the prospect of being burned or trapped in a small interior space is uniquely terrifying. Marines on Iwo frequently reported that once a flamethrower tank arrived, resistance within certain complexes collapsed or became significantly less coordinated. Such testimony is consistent across survivors' accounts and after-action commentary. Many infantrymen expressed gratitude and relief at the prospect of a flamethrower being brought to bear before they had to clear a cave themselves.
Propulsion, speed, and mobility. The M113 and M132 shared drive characteristics, originally powered by a Chrysler 75M petrol engine in early M113s, and later by a General Motors 6V53 diesel in the M113A1 and the M132A1. Suspensions were torsion bar with 5 road wheels per side, front drive sprockets, and rear idlers. The top road speed remained about 42 miles per hour, 68 kilometers per hour, giving a mechanized flamethrower the same operational mobility as the APCs and allowing them to keep up with armored columns, amphibious landing craft modifications, or riverine groups. Flame system architecture: M10 fuel and pressure unit plus M8 flame gun, cupola group. The E31-E36 kit idea and its tested evolution into E31R1, E36R1, and eventually M10-8 shows a modular philosophy. The system, as standardized in 1962-63, contains M10 fuel and pressure unit, the supply side, and the M8 flame gun, cupola-mounted projector, together called the M10-8. The M10 unit consisted of 4 primary spherical fuel tanks, each about 50 U.S. gallons, or 227 liters, arranged in snowman-like pairs, a large fuel sphere topped by a smaller compressed air sphere. Fuel tanks were pressurized to roughly 325 psi, or 23 kilograms per centimeter squared, and the air tanks to about 3,000 psi, or 210 kilograms per centimeter squared. The tanks were connected in series for fuel flow. Air tanks were linked to provide system pressure to both fuel and flame gun. For maintenance and logistics, the entire tank assembly was placed in removable racks. Fuel capacity and firing time. The M132 carried 200 U.S. gallons, or about 909 liters, of thickened gasoline-based flame fuel. That amount yields a relatively short continuous burn time, around 32 seconds of lit firing in practical use, according to contemporaneous XM45 refueling vehicle doctrine and field reports. By contrast, earlier M59-based test installations had a 400-gallon capacity, or 1,818 liters, and therefore longer continuous firing times, around 70 seconds in trials. But the M59 family was supplanted by the M113 for logistical commonality, despite the less favorable fuel endurance. The trade here is clear: a smaller, more modern chassis with better overall fleet commonality versus a larger capacity on an older vehicle. In combined arms thinking, the decision favored commonality and the M113's other benefits. Projectile characteristics, ranges, and fire modes. The M8 projector could throw thickened fuel between roughly 12 and 218 yards, or 11 to 200 meters. That broad range is a function of fuel viscosity, pressure, nozzle design, and environmental conditions. Doctrine allowed several firing techniques: direct lit bursts and the wet burst, then lit burst tactic that dates to World War II flame tank doctrine. The wet burst technique sprays unignited fuel onto a target or into a bunker throat first, saturating fibers, combustibles, or the enclosed volume. A second, ignited burst, then flashes the soaked.
Production and variants. FMC produced 351 vehicles, 201 M132 Standard B and 150 M132A1 Standard A. The M132A1 corresponds with the diesel-powered M113A1 hull. The M132 was assigned primarily to Army armored cavalry units, with doctrine recommending 4 M132s and 2 regular M113s per regiment for Vietnam tasks. ARVN armored regiments were typically given 4 M132s each. The M67 Zippo, the M48-based flame tank, served largely with the U.S. Marine Corps and had a different fuel system and larger capacity, but the doctrinal and ethical debates that influenced the fate of both vehicles are parallel. Tactics, doctrine, and combat employment. How flamethrower vehicles were intended to be used, examples from Vietnam adapted to Pacific thinking, and comparison to Iwo Jima era needs. The military calculus behind mechanized flamethrowers is straightforward. You need a way to clear entrenched, protected enemy positions and to deny or neutralize complex fields of fire, such as bunkers, caves, and dense vegetation that conceal mines or booby traps. In World War II island fighting,
infantry and tanks had to contend with interlocking tunnels, high-angled embrasures, and 20 to 30-meter engagement arcs, where indirect fire could not safely or quickly root out defenders. The flamethrower, by producing intense heat and toxic combustion gases inside enclosed volumes, could render a bunker untenable. Post-war doctrine attempted to replicate that utility with greater operator protection and mobility. Standard M132 combat procedure. The M132's basic attack cycle was 1. Advance using the coaxial M73 machine gun to suppress visible defenders. 2. Close to flamethrower range while maintaining suppression. 3. Discharge the flame gun in short bursts, potentially using wet bursts followed by ignited bursts when targets were enclosed or suspected to be within covered positions. The wet burst technique, first saturating a target zone with unignited fuel, was used to soak timbers, foliage, or the interiors of bunkers. A subsequent ignited burst then produced maximal internal combustion. This two-step approach is tactically useful against layered defenses, but it increases the time and exposure required to complete an engagement. Employment patterns and unit composition. In Vietnam, the Army Concept Team in Vietnam, active, advised attaching 4 M132s and 2 regular M113s to each regiment. Headquarters companies had at least 1 M132. ARVN armored regiments received 4 M132s each. M132s were commonly employed in pairs for search and destroy missions against bunkers, dense foliage with anti-personnel mines, and booby trap fields. The flamethrower's ability to heat steel and
Comparisons to World War II island warfare. Iwo Jima. Translating Vietnam-era use back to Iwo Jima context shows both consistencies and mismatches. Iwo Jima's defenders occupied volcanic ash tunnels and bunkers with narrow choke points. Flame was effective precisely because it could be delivered into enclosed spaces. However, in 1945, the specialized Churchill Crocodile and POA CWS H-1 Sherman provided larger fuel loads and were integrated into combined arms amphibious assaults. The later M132's advantages, better mobility, protected operator, and fleet commonality, would have been attractive on Iwo Jima, but the M132's 200-gallon fuel capacity and 32 seconds of firing time contrasts with the crocodile-style solutions, which had larger tanks and longer burn times. In short, an M132-like vehicle would be tactically useful on Iwo Jima for quick, protected flanking or bunker-clearing runs, but sustained operations and the higher fire endurance needed for massed clearing tasks might favor dedicated heavy flame tanks or combined demolition teams. Employment risks and limitations. Flamethrower vehicles faced acute dangers. Thin aluminum armor made them vulnerable to anti-armor weapons. The need to close to effective range exposed them to mines, recoilless rifles, and anti-tank guns. And fuel tanks create a hazardous survivability profile if hit by penetrating rounds or incendiary devices. For these reasons, doctrine emphasized using flamethrowers with infantry and heavier armor to screen them and to limit exposure. Also, flame systems had maintainability issues. The high pressures, 3,000 psi air spheres, and corrosive, thickened fuels required skilled maintenance and regular refueling, tasks that the XM45E1 service vehicle addressed, but which added to the logistic burden. The horrors and effects. Operational outcomes, physical and psychological effects on defenders and attackers, case studies and anecdotes, ethical and humanitarian considerations, tactical effectiveness, and the physical reality of fire. Flame, especially thickened, gasoline-based incendiary mixtures designed to cling to surfaces, kills by 3 primary mechanisms: thermal destruction, burns, smoke and toxic gas asphyxiation in enclosed volumes, and secondary effects like structural collapse or detonation of munitions inside bunkers. In close, confined spaces, such as caves and pillboxes, temperatures can rapidly exceed survivable thresholds. Thickened fuel that drips into crevices will burn hot and produce dense smoke and carbon monoxide, overwhelming those inside. From a purely tactical viewpoint, flame is devastatingly efficient at clearing enclosed positions without having to invest time and explosives to enter openings. Psychological effects. Flame has a uniquely terrorizing effect. Combatants confronted with an advancing projector or with flame entering their position face an instinctive horror, the prospect of being burned alive or suffocated. This produces both immediate tactical effects, rapid surrender or withdrawal, and long-term moral and psychological injuries among both users and victims. Units employing flamethrowers often reported mixed feelings, a professional recognition of the weapon's utility, and a discomfort with the nature of its effects. For the attacking infantry operating alongside mechanized flame vehicles, observing victims of incendiary assault could be traumatizing. Case studies and anecdotes. The supplied history includes battlefield reports such as the Op-Tuau engagement, where an M132 neutralized a recoilless rifle team with a brief burst. Another documented role was heat-induced detonation of mines and booby traps. Flame directed at mined, vegetated roadside belts could cook off pressure-fused anti-personnel devices and reveal hidden threats. In Vietnam, M132s sometimes acted as convoy escorts, using suppressed fire and flames to deter or eliminate ambushers concealed in dense vegetation. Humanity and law. Incendiary weapons, including flamethrowers, occupy an uneasy legal and moral space. International humanitarian law distinguishes between weapons that cause unnecessary suffering and those that are militarily necessary. Incendiary weapons used against civilians or civilian objects are restricted under Protocol 3 of the Convention on Certain Conventional Weapons, which was adopted later, in 1980, and regulates incendiary weapons in part. The U.S. phased out mechanized flamethrowers by the end of the 1970s, citing both operational considerations and humanitarian objections. The official rationale in 1978 stated that flamethrowers were not effective in modern combat scenarios, but that practical claim sits alongside ethical unease about their brutal effects. The historical record shows that flamethrowers caused horrific injuries and deaths, extensive burns, inhalation injuries, and destruction of living spaces, which are facts that cannot be sanitized by technical description.
Survivability and operator hazard. From the operator's perspective, the combination of pressurized tanks and volatile fuel makes flamethrower platforms hazardous if struck. Although tanks and armored vehicles in general present survivability risks, flamethrower vehicles carry additional catastrophic failure modes: ruptured fuel tanks leading to massive internal fires, or loss of pressure resulting in system failure at critical moments. That operational vulnerability was one reason doctrine required flamethrowers to be used with protective screens of infantry or heavier armor. Legacy, phase-out, and historical assessment: why mechanized flamethrowers fell from favor, what they achieved, surviving examples, and how history should remember them. Why they were phased out. Several intertwined reasons explain the M132 and M67 being taken out of service by the early 1980s. Operationally, the advent of precision munitions, improved demolition charge techniques, and changes in combat environments, favoring standoff engagements and area effect weapons, reduced the necessity for close-range flame systems. Logistically and tactically, limited fuel capacity and dangerous survivability profiles made flamethrower vehicles a liability in environments dominated by anti-tank guided weapons and heavier anti-armor threats. Ethically and politically, incendiary weapons increasingly attracted negative attention. The horrific injuries associated with flame made their use controversial in the court of public opinion. Officially, the U.S. discontinued all flamethrower types in 1978, citing ineffectiveness in modern combat, but the moral dimension undoubtedly contributed to the decision. By the early 1980s, both the M132 and M67 had largely been removed from frontline inventories. What they achieved. Mechanized flamethrowers filled a set of tactical problems with unique solutions. They allowed assault elements to engage and clear bunkers, caves, and dense vegetation quickly. They could detonate mines through heating and defoliate terrain. They provided convoy protection in vegetation-choked routes, and they served in riverine contexts where other solutions were impractical. From a technical standpoint, the M10-8 system proved adaptable. Cupola-mounted flame projectors with modular pressure fuel units were serviceable and effective in many tests and operational instances. The M132's flexibility, being based on the ubiquitous M113 chassis, made it a clever piece of systems engineering. Surviving examples and historical memory. A few M132s survive in museums, one at the War Remnants Museum in Ho Chi Minh City and another at the United States Army Chemical Corps Museum at Fort Leonard Wood, Missouri. These preserved examples provide a tangible link to a weapon system that many today find morally difficult to contemplate. The archiving of these vehicles in museums underscores a dual duty: to remember the technical ingenuity and to confront the human cost the weapons produced. Historical assessment and nuanced judgment. Accurate historical assessment requires both technical specificity and moral clarity. The M132 and its cousins were tools built for particular tactical tasks. In the context of their era and the conflicts in which they served, they provided capabilities that commanders valued. At the same time, those capabilities produced suffering on a scale and of a kind that modern military and humanitarian norms find repugnant. For an American audience, remembering the M132, the M67, and their World War II antecedents should be an exercise in complexity, acknowledging effectiveness while refusing to sanitize the human horror the weapons produced. Conclusion and honest note about scope and next steps. This script has presented an integrated analysis of mechanized flamethrower development, design, tactical employment, effects, and legacy, fully incorporating the detailed technical lineage and field data in the material you supplied. The E31 to E36 kit evolution, the M10-8 standardization, the M132 and M132A1 production figures, 351 total, with 201 M132 and 150 M132A1, the fuel and pressure specifications, 50-gallon spherical tanks, 325 psi fuel tank pressure, 3,000 psi air tanks, the ranges 12 to 218 yards or 11 to 200 meters, the firing times 32 seconds for M132, 70 seconds for the dropped M59 test installation with 400 gallons, and doctrinal employment in Vietnam. Recommended 4 M132s per regiment, pairs for search and destroy, naval riverine employment, and the XM-45E1 refueling vehicle.